Hello, I am Pankaj Sharma from Brainleague Learning. In this video, we will learn what CMOS stands for and why it is so widely used in digital electronics. Complementary means we pair a P-type transistor with an N-type transistor. Together, they form the heart of digital logic, the inverter. When the input is low, the P device is on and the N device is off, so the output is pulled up to VDD. When the input is high, the P device is off and the N device is on, so the output is pulled down to ground. Benefit 1. Very low static power consumption. When the input is steady, only one transistor conducts. There is no direct path from VDD to ground, so the static current is almost zero. Benefit 2. High noise immunity and a wide operating voltage range. The inverter transfer curve stays close to the rails, so small input noise does not flip the logic state. The green line marks the lower input threshold VIL, and the red line marks the upper input threshold VIH. Inputs between 0 and VIL are reliably seen as low, and inputs between VIH and VDD are reliably seen as high. Benefit 3. Very high integration density. Modern chips pack billions of CMOS transistors on a single die. This dense grid represents many tiny devices packed closely together. Benefit 4. Scalability. As device dimensions shrink, we fit more transistors, switching gets faster, and cost per function goes down. Benefit 5. Good switching speed for most digital applications. We can see a transition ripple through a chain of inverters very quickly. Watch the logic level propagate from input to output. To summarize, CMOS stands for Complementary Metal Oxide Semiconductor. Its key benefits are very low static power, high noise immunity and wide voltage range, high integration density, excellent scalability, and good switching speed for most digital applications. Thanks for watching.